Right, so with that, let's kick off with our lesson today. On Tuesday, just to recap what we did on Tuesday. So on Tuesday, we did all the basic formula, the distance formula, we did gradient, we did midpoint, we found the equation of a line, etc. So that is everything we did on Tuesday. So today we're going to, and that was very much your sort of grade 10 content, so and your grade 11 content. But today we're definitely going to focus on something you would have learned in grade 11, which is the angle of inclination. Remember, all of these concepts will be tested in your exam. Angle of inclination, distance, midpoint, finding the equation of a line, all of that stuff will be in your exam, in your grade 12 exam. Right, so let's have a look at the angle of inclination. What are we talking about when we're talking about the angle of inclination? So the angle of inclination is related to the gradient. So from Tuesday's lesson, or maybe from any time before when you've learned analytical geometry and from doing your straight lines, you know that the gradient is y2 minus y1 over x2 minus x1. So the change in y over the change in x. That is what we've been doing for the gradient since the start of working with straight lines and with analytical geometry. So if we look here at this point A, the coordinates for point A are 2 and 4. And this point here is the origin. So remember, the coordinates at the origin are 0 and 0. So to calculate the gradient of this particular line, we can go 4 minus 0. So change in y will be 4 minus 0 over the change in x. So 2 minus 0. That gives me the gradient of 4 over 2, and that equals to 2. Right. But now we're going to mix a bit of trigonometry in here. And remember, for those of you who have been around for a while, we did trigonometry not so long ago. And it's one of the courses that you can go and catch up on our website if you want to have another look at your trigonometry. But if we now say this is angle theta, and angle theta is the angle that this line, we still have the same line, there's point A, there's point O, and if I want to calculate the angle theta, the angle that that line makes with the x-axis, I can make a little triangle and I can say, okay, this vertical distance is 4. It's 4 because the y coordinate is 4. And you can see here is my y coordinate. I'm going to highlight it over here. So this vertical distance is 4. And the horizontal distance, which is my x coordinate, will be 2. So this distance here is 2. Now, if I go back to my trigonometry, then, and I look at angle theta, then this will be the opposite, the adjacent, and the hypotenuse side. And that so happens that if I say tan of this angle, tan, which is opposite over adjacent, that actually gives me the same. It gives me 4 over 2, which is 2. And that is actually the same as what I got over here when I calculated the gradient using this formula. So the gradient and this tan of theta is the same value. So tan theta is equal to the gradient. Okay, so that is something that you must know. It is on your formula sheet when you are in grade 12, but we also need to know how to work with it. Okay, so if we want to calculate the theta, the angle, which we just worked out, tan theta is 2, then to get that angle, you go on your calculator and have your calculator ready to make this, to do this calculation. So we go shift tan of 2, and that gives me 63,43. So that angle will be 63,43, and it is the same as the gradient. Okay. So let's have a look at what theta can be. So theta, very important that this angle that we are working out for the gradient is the angle that the line makes with the positive x-axis. So it can only work when you are looking at the positive x-axis with theta. That's the only way that you can calculate it. Okay, now that angle can be acute. Remember, acute means that it is smaller than 90 degrees. Or that angle can be an obtuse angle. So here's my positive x-axis, my theta, my angle, that is theta, makes this obtuse angle, and for that, the gradient is normally negative. So if the gradient is positive, we have, so if m, let's say m is greater than 0 or m is positive, then we have an acute angle. And if the gradient is negative, then we have an obtuse angle. Okay, but let's see how all of this works. But important takeaways from here is that tan theta is equal to your gradient, that you can get theta if you say shift tan on your calculator to get the angle, and that that angle is in relation to the positive x-axis. The angle can only be between 0 and 180, okay? And we call this the angle of inclination. Right. Let's start and have a look at calculating this angle. So I'm going to do the first one and then we see how it goes. So for this first one, we have the point 1 and 2, and we have to calculate theta, the angle of inclination in each case. So we're going to start by saying, what is the gradient? Okay, so first I need to calculate the gradient because I know that tan of theta is equal to the gradient. The gradient we calculate like we normally do, y2 minus y1 over x2 minus x1. This line goes through the origin, so this is actually 0 and 0. So y2 minus my y1, I'm going to say 2 minus 0 over 1 minus 0. That gives me 2 over 1. So my gradient is 2. If I now want to calculate what theta is, I can go tan theta is equal to 2. And on my calculator, go shift tan and that will give me my angle. So shift tan of 2. And please pop your answers in the chat so I can see if you are finding the angle and following along. As soon as you have the angle, pop it in the chat and let us know what you find. Okay, lots of 63,43. Wonderful, everyone. 63,43. Great stuff. Okay, let's go on to question 2. And I'm going to leave you alone to do this one. I'm going to give you about 2 minutes till about 18 minutes past 17 to do question 2. 33, some say it's 58. Okay, let's see. Got a few more seconds left for everyone to put their answers in. I'll start writing down about the gradients so long. By the way, our teaching assistant is Miss Coco. For those of you who are new, and for those of you who have been here for a while, you probably know her already. And she's not a big fan of analytical geometry. So I think we must ask her, put her on the spot.
Oh, ma'am.
Ask her to do a few questions on analytical geometry.
I can't believe you do this to me, ma'am. I'll give it my best.
To learn.
I will give it. I'll give it a really good shot. But guys, just like you, I can't guarantee that I'll also give the right answer.
See, there's Asha telling you. I think Miss Coco should take the quiz. Okay, Kayla, yes, the sign does count. Remember, if it's a negative gradient, then we have an obtuse angle. But let's just get through this one, and we can do one like that with an obtuse angle. So 1 minus minus 3, remember that's going to make it positive, and 4 minus minus 2 is going to make that positive as well. So 1 plus 3 is 4, and 4 over 6, if I believe my calculator, is 2 over 3. Okay, now we've got the gradient is 2 over 3, so we go tan of theta is 2 over 3. To get tan, I go on my calculator, shift tan 2 over 3, because if it's 2 over 3, what is my angle? Shift tan, whoops, 2 over 3, and that gives me not the right answer, 2 over 3. Here we go, that's better. Okay, great stuff. It looks like everyone got this one right. 33,69 degrees. Wonderful. Okay, if you got something different, make sure you calculated your gradient correctly and that you are finding your way through calculating with your calculator. Okay, next up, question 3. Again, we're going to do, seems like they don't need 2 minutes, hey, Ms. Coco? It seems like they only need a minute. So at 17:21, and then I want Ms. Coco to give an answer as well.
Oh gosh, I was about to say 2 minutes for both, but now that also puts me under pressure. I'm like, let's go, guys.
Okay.
Let's do this. Let's go. Let's go.
So we're doing question 3 while Clotlanyo, wow, that's a nice name. I love that name. While you get to ask your question, go for it.
With question 2, I did exactly the same thing and I got 33,82.
Did you put in 2 divided by 3?
Yes, 2 divided by 3. Yes, I did.
I'm not sure why, because I think everyone else got the same, and it's 33.69. Make sure that it is 2 over 3 that you put in, and not 0.66, or that you round it somewhere along the way.
Oh, okay.
It must be 2 over 3. Yeah.
Okay, thank you.
Okay. Okay, everyone who's putting down a negative answer needs to go and rethink. The angle cannot be negative, okay? The angle can be obtuse, but it can't be negative. Okay, time is up. But keep working if you don't have an answer yet. And if we have a negative angle, we don't just change it to a positive. That is not how it works, guys. We can't just throw the negative away because it doesn't suit us. Let's see. The gradient is 2 minus 0 and minus 1 minus 0 because this is the origin. Okay. We get y is 2 over negative 1, and that is negative 2. Why am I saying y when it's actually m? Sorry about that. M and m. Okay, so the gradient is negative 2. So there's two ways in which we can do this. So our gradient tan of theta is negative 2. So when we go to our calculator and ask our calculator to tell us what our angle is if the ratio is negative 2, we can ignore the negative and just put in shift tan of 2. That's going to give me 63,43. But we can see that when the gradient is negative, we have an obtuse angle. So what the calculator is actually giving us when it gives us 63,43 is this angle here. But if we want the obtuse angle, we need to go 180 minus 63,43, and that is 116,57. Another way that you could have done it is to go on the calculator and say, okay, tan, shift tan of negative 2. So you put that in and you get negative 63,43. But we can see that this is an obtuse angle. So we add 180 degrees to it. So if you add 180 degrees, then theta is 116,57. Okay, so that's our final answer. It cannot be negative. And if you just did 63.43, you must think again because theta is actually obtuse. So you still have to take that 63,43 and subtract it from 180. Okay, I think we need another shot at this type of question when the angle is obtuse. So let's do question 4. We'll check back in about a minute and a half. We must check if Miss Coco is right. Are you copying the answer from the other learners, Miss Coco?
No, I just waited for someone to put in an answer and then I just copied what it was. Yeah.
Okay. Cool. Okay. Good stuff. 139.40. So let's see if that's right. If Miss Coco and everyone else is right about this, let's see if I'm right. Who knows? Maybe I get the answer wrong. So minus, but then all of you can check my answer. Let's see. So 3 minus 3 minus 2 minus 5. So 3 plus 3 is 6 over negative 7. Okay, so now we can go to a calculator and say tan of theta is negative 6 over 7. So theta, now I'm going to do it this way, where I ignore the negative and just ask for the angle. So shift tan 6/7. I keep forgetting to press the shift button, then I get the wrong answer. There we go. So that is 40,60 with a couple of decimal places. So that angle is actually 180 minus 40,60. Okay, and I think we all got it right. 139,40. Yay! Well done, Miss Coco. Good stuff. Okay, great. Let's see. Please put a thumbs up or a thumbs down or any other emoji in the chat to tell me how you're doing with angle of inclination so far. Let's have a quick check-in. Let's see how everyone is doing. Great. You guys are awesome. You're really doing well. Smashing it. Smashing it. Oratile has a question. Go for it, Oratile.
Oratile, your mic isn't connected, so you're going to have to type it in the chat for us, please.
Okay, I'm going to continue, Oratile, because unfortunately we can't hear you. Okay, so now it doesn't end there. It obviously goes a little bit further, as it always does in maths. The angle of inclination, it's important. So what do we do when the angle of inclination, that angle that we were looking for, does not intersect the x-axis? Okay, so what if we have an angle, if the question says solve for this angle over here, then one way that we can solve for this is by drawing, just for ourselves, on our diagram, on our sketch, a line that is parallel to the x-axis. Because if I draw parallel lines to x-axis, then I can use stuff like corresponding angles and alternate angles and co-interior angles. Okay, so parallel lines can help you to find angles of inclination that's not forming with the x-axis. Okay, because you can use alternate, corresponding, and co-interior. But we also have other geometry that we can use, especially with triangles. It comes in very handy with these types of problems that we're going to do next, to use the angle sum of a triangle and the exterior angle. So the exterior angle equals the sum of the opposite interior angles. So those bits of geometry come in very handy when we are working with these triangles, with these angles of inclination. Right, so let's see. Okay, so here's an example where none of the angles are actually formed with the x-axis. So remember, our angle of inclination, we can only do it, we can only work out the angle of inclination if as the angle is made with the positive x-axis. Okay, so if I start here and I have to solve for theta, beta, and alpha, none of these actually form with the x-axis, but I can draw some lines for myself to help me figure this out. Okay, so if I extend this, and I can say that this is parallel to the x-axis, then if I start with beta, beta is actually the same as this angle here. And that angle I can find by calculating the gradient of BC. So let's start there. Gradient of BC. The gradient of BC will be 4 minus 1 over minus 2 minus 4. So 4 minus 1 is 3, minus 2 plus 4 is 2. So if I have that, then I can go tan beta is equal to 3 over 2. And then beta will be shift tan 3 over 2. Which is 56.31 degrees. Okay, and I'm going to write it in here so that I know I've now solved for this one. Okay. Have a look at alpha, and then put in the chat any suggestions you have about solving for alpha. Let's see. What do you guys think? How can we solve for alpha? You don't need to solve for alpha yet. You can just put a suggestion in the chat about how you think you'll go about it. Cos rule, yo, you guys are thinking out the box here. Sum of angles in a triangle. I like Tatu Sokela. I like that idea. Draw a line that cuts through the x-axis. Okay, you've been listening nicely, Tatu. That is exactly what we're going to do. Okay, let's extend this x-axis. I know you want to do cos rule and all of that, but for cos rule, we need distances. And that's a whole lot of work, I think, if you use cos rule for this. So let's just extend the x-axis and extend this line. And then we see that, again, that line is parallel to the x-axis. So these angles are corresponding. So we can just calculate the gradient and then do shift tan alpha to find what that angle is going to be. Okay. The gradient of AC. Yes, good stuff. I say again, guys, cos rule is a lot of work for this because you would first need to calculate the distances, and you don't have angle theta, so you only have beta so far. So quicker way, I'm not saying cos rule is wrong, but it will take a long time. So the gradient of AC, okay, and as soon as you have the answer, you can put it in the chat. Let's find the gradient of AC first. So that's 4 minus 1 over minus 2 minus 2. 4 minus 1 is 3 over minus 4. Okay, by now we shouldn't be surprised that we're getting a negative answer because we can see that the line slopes negatively. Okay, I shall be with you in a second. We're just going to finish the question. So now we go tan of theta is 3 over negative 4. So shift tan of 3 over 4 on your calculator is going to give you that angle. Be careful though, because it is an acute angle. So make sure that when you use your calculator and you're working out the angle that you use, that you're actually finding the correct angle. So shift tan 3/4 gives me, it's acute, and the angle I'm working with is acute. So that's great. That is the right answer. 36,87. Let's see what people put in the chat. 36,87. If you said 143, don't get confused with the angle that you're actually working out. Okay, we're not working out this angle. This is the obtuse angle. We are working out this angle, which is the acute angle. Okay, so you have to think about the question and what the question's asking. Be careful not to just blindly do what we did before, because we are now working with a negative gradient. Think carefully about what the question's asking. It's asking for the acute angle. Okay, now that we've got theta, let's find the final angle. Sorry, now that we have alpha, let's find the final angle theta in the shortest possible way. Okay, please put your answer in the chat with your reason if you know what theta is. Asha, you have a question. Asha, you've raised your hand, so please unmute yourself and ask your question.
Ma'am. Yeah, so I just can't see how we determined that tan beta. Okay, because you know what I'd do? Initially how I'd do it is that I'll just take the so from point B to C, I'll just maybe calculate theta as 56.31. How would that not happen? I don't know. Like, what made you say I'm going to start with beta and then follow with theta instead of? I don't know.
Okay, so theta is not an angle with the positive x-axis. So we can't just go shift tan the gradient of BC to find theta. Theta is, do you see it's in a triangle and it's in the top corner. So it's not an angle that's made with the x-axis. So we can't, so that can't be the first thing we do. It's going to be tough. What we can then find is beta. So beta, I showed you how to draw the lines to create the parallel lines so that we can find what beta is, and then we apply the same thinking with alpha. Now for theta, and a few people have got it, and it's in the chat, we're going to use the sum of the angles of a triangle to go 180 minus 56 minus 36.87, and that's going to give us theta. Okay, so theta, I agree with everyone, minus 56.31 minus 36.87, and that is going to be 86.82. Okay. Right, I think we have time for one more before we have to kick off our quiz. Let's go to question 2. And I want everyone to just give it a go for the next 3 minutes. I think my screen might have gone away for a second, but it's back up. Okay, so at about 1:45, we'll check in about question 2. As soon as you have your answers, though, feel free to pop them in the chat. Rihad, those are constructions that you make for yourself on your sketch by extending the side or by making drawing in a line that is parallel to the x-axis. Right, so we can start definitely with theta, because theta is an angle that's made with the positive x-axis. So the gradient for AC is -2. So we can find what theta is by going tan theta is equal to -2. And then theta is obtuse, so we go shift tan -2 and then add our 180 to it to get the obtuse angle. That's 116,57. The gradient of AB is 4/5, so tan theta is equal to 4/5. Sorry, not theta, this is beta. Beta, so beta is shift tan 4/5. On the calculator, that gives me 38,66. I see quite a few people are getting that. Okay, I see there are some hands. We're just going to finish the problem and then I will answer. Now, how are we going to get alpha? Again, alpha is nowhere near the x-axis. So we can do alpha in two ways. I think the easiest way is to use the exterior angle of this triangle. So there, I've highlighted the triangle. We've got theta is 116,57 and beta is 38,66. So beta plus alpha must give me theta, because theta is the exterior angle. So exterior angle is equal to the sum of the opposite interior angles. So theta will be 116,57 minus 38,66. And that gives me 116.57 minus 38.66. Okay, 77,91. Right, there's a few questions. Taniko, what is your question? Go ahead.
Ma'am, So at the denominator for the gradient of AC, there's 2 minus 3. So shouldn't it be equals to -1 after that?
Oh, I see that, yes. 6. Oh, thanks. -1. So that's -6. Okay, then we just need to make a few changes here. -6. So tan of -6. Okay. Just going to make a few quick changes. So tan of -6 is let me also fix this over here. Okay, so that's 80. That angle is 80,53 degrees. But it is obtuse, so we actually have to subtract from 180. So yeah, shift tan -6 plus 180 gives me 99,46. Okay, so this one's right, I think. Ms. Coco, are you checking that I've done this correctly? 3 plus 1 is 4, and 2 plus 3 is 5. I got that. Okay, and then that's 38,66. And then from the exterior angle, we are going to subtract 38,66, and the exterior angle is 99,46. So 99.46 minus 38.66. There we go. That should be better. That should give me 60,8. Yes, guys. So tan theta is -6. So the angle is actually 99,46. Beta is 38.66, and we use the exterior angle to work out what theta is. So we go 99 because we have the exterior angle, sorry, alpha, to work out what alpha is. So alpha is 60,8. Okay, there we go. Right, thank you, everyone. I think it is time for us to do our quiz. Ms. Coco, have you got the link for the quiz available?
I do. I'm about to pop it into the chat right now. Yeah, guys, remember, if the link that I just put in the chat isn't working, please just log back into watobe.co.za, and exactly where you found the link for today's lesson, you're going to find the quiz as well.